This we use a 120 to 40 volt center tap transformer, a full wave bridge rectifier, 4 smoothing capacitors. We have a 5 volt voltage regulator, 13 volt regulator, negative 13 volt regulator. We have our adjustable 0 to 12 volt regulator, 0 to -6 voltage regulator, and our negative 28 and positive 28 voltage regulators. This is the full circuit. So for a square wave generator, we have the logic circuit. As we turn it on, you see, and we have a potentiometer that measures the frequency or varies the frequency of the square wave. In order to prove that we got the square wave generator up to a megahertz, we can see here by the frequency adjuster that we got it up to 1.3 megahertz, and it still look pretty squarely. As we go up to 2, the signal gets less attenuative. Here's the square wave at 2.5, 2.6 megahertz. That's our max. To switch between the waveforms, we just change the oscilloscope input here, and as you can see, now we have a sawtooth generated waveform at 70 hertz. We can vary the hertz or the frequency from the waveform, the amplitude, and the frequency. And show the potentiometers. Here, I'll show it again. Again, to change for a triangle waveform, we change to the other input, and as you can see, we get a perfect triangle waveform. And again, to vary the frequency, we play with the potentiometer. To control the duty cycle of our square wave generator, we use this potentiometer to go from 0 to 50. As you can see, it goes from 0 to 50. Now to control it from going to 50 to 100, same potentiometer, with just a flip of a switch, will go from 50 to 100. To create our sine wave, we use the buffer for the input to the two BJTs, 3904, and the potentiometer to create our sine wave generator. And here we can control it a bit so you can see the refinement of it and the frequency. That's our sine wave. To control our positive DC offset, we use this potentiometer, and to control the amplitude, we use these two. And as you can see here, the full range of our DC offset. This is caused by the saturation of the op amp. As you can see, it goes. And then with the amplitude, we can control this. Now to control a negative DC offset, we use this potentiometer. And as you can see here, it falls towards the negative side. Let's explain there it is. So this is caused by the saturation in the op amp. At the output stage of our power amplifier, the OPA 548, we can control all the alterations previously mentioned to all the waveforms, like the duty cycle, the DC offset, the amplitude, the duty cycle, and the frequency. We can do this to all waveforms, but we're just going to show you for this one first.